Hello, very good morning to all of you. So, in this lesson, we'll discuss about annulines, and this annuline topic is very important starting from JEE NEET and also for those who are studying BSc honors or MSc. So, this is a very universal topic, and I hope this video helps a lot. So, let's start. So, first of all, what does aniline mean? What are annulines? So, basically, annulines are they are monocyclic hydrocarbon. Basically they are hydrocarbons, monocyclic hydrocarbons containing conjugated double bond. Okay, so the hydrocarbon will contain conjugated double bonds, and generally they are represented by CnHn when n equals to even, like C6H6. So that's why benzene is also an aniline. Okay, in many book you can find that benzene is aniline. So the first example, I'll just discuss all the examples, the important examples. Now see, these aniline are represented like this. Here it's 4 aniline. So 4 means the number of carbons involved in this aniline cycle are 4. Okay, so the 4 aniline means 4 carbon and conjugated double bond. That means it's nothing but cyclobutadiene, isn't it? Now here see, we know that when there are 4 and pi electrons, okay, so then it becomes anti-aromatic, and of course it must be cyclic, it must be planar and conjugation, and otherwise it's non-aromatic. So here you see it is having 4 electrons, 4 pi electrons. That means it becomes what? That means it becomes anti-aromatic. I'm writing as AA. Okay, now the next example is 8 aniline. So 8 aniline, oh sorry, not 8, 6. I just skipped benzene one. Okay, so 6 aniline means benzene because 6 carbons are involved, C6H6. Okay, so 6 carbons are involved, and now you see it's having what? It's having 6 pi electrons, that is 4n plus 2 pi electrons, and also cyclic plan and everything. So it is aromatic, that is A. Okay, now the next example is what I have just written before, that is 8 aniline. Now 8 aniline means it's very important. Okay, so it is what? Cyclooctatetraene. Cycloocta, 4 double one, that means tetra N. Now here see, it is having 1 2 3 4 5 6 7 8 pi electrons. That means it should be anti-aromatic. Now see, the order is, stability order is first of all aromatic, then non-aromatic, then anti-aromatic. Anti-aromatics are highly unstable. So in the most of the example, you'll find that when the compounds becomes anti-aromatic by some means, then it tries to at least convert to non-aromatic to decrease its instability. Okay, so that it can be at least a little bit stable. That's why it tries to attain a structure where it becomes non-aromatic, that is, it goes out of planarity. Now here see, it should be anti-aromatic, but it is actually found non-aromatic. Okay, what happens now? This compound, it behaves smartly. So it thinks like, if I become anti-aromatic as it is prescribed here, so I'll be the most highly unstable. So it does what? It converts in such a structure so that there is no more planarity. And for anti-aromatic compound, the one of the most condition is it has to be planar. So this compound goes out of planarity, becomes non-planar, and it assumes a structure like this. Let me draw the structure. so that you will get the idea. It actually assumes a structure like this. This is a tub-like structure. It looks like tub, isn't it? It's a tub-like structure. So by assuming this structure, this compound becomes what? Non-planar. Now this compound is non-aromatic. So ultimately, this compound becomes non-aromatic. Okay. I hope it's clear to all of you. Okay. Now let's move to the next example, that is 10-aniline. It's also important. Now see, 10-aniline are actually having 3 hypothetical forms, but I'll only write 2 because in the maximum books you'll find only these 2 isomer, 2 forms. So I'll just write these 2. So the first one, we all know cis and trans isomer. Trans means the bigger group are on the opposite side, cis means on the same side. Now see, if this 10-aniline assumes this structure like this, 3, 4, 5, 6, 7, 8, 9, 10. If it assumes this structure and this conjugated double bond, here see, all the bonds are cis because hydrogens are outward. See, right? All the hydrogens are outward. That means it's what? It's all double bonds are in cis position, isn't it? All double bonds are cis. All cis. And in also we'll learn later that in a cis isomer we can, in case of cis double bond, we can also represent it like Z. Okay, so Z. Now see, in this cis isomer, these all carbones are sp2 hybridized, so it is expected that the bond angle will be 120 degree here, isn't it? But here actually the bond angle is around like 144 degree. Now you see, it should have been 120 degree, but it is actually what? It is actually 144 degree. That means it's highly strained, so that it becomes non-planar and it becomes non-aromatic. Okay, I hope you understood the concept. Now here see, it can assume another structure, another form like this. Conjugation. Okay. Now see, if this is sp2 hybridization, that means another hydrogen must be here, and this is also sp2 hybridization, then the hydrogen must be here. So now this bond, these two groups are on opposite side, that means trans. Here also see, here also see, the hydrogen is here and another hydrogen is here, that means it's also trans. Okay, so in this case trans we represent like E and this bond is Z, cis, this is Z, this is Z. Okay, now see here what happens, these two hydrogens, they actually repel each other. Okay, so two hydrogen repel each other, two hydrogens repel each other, so that now it becomes non-planar, and this form also becomes non-aromatic. So here also this one becomes non-aromatic, all cis, and here also it becomes non-aromatic. Okay, Now let's move to the next example. So if in question, this question comes like the 10 aniline is aromatic, anti-aromatic, non-aromatic, we'll tick mark non-aromatic, okay? So the next example is 12 vanillin. Now, in case of 12 aniline, let me first draw the structure. So, conjugation, right? Here also sp2 hybridization. Here also the hydrogen's repulsion. Now you see it's 12 vanillin. So it is expected. It's expected to be anti-aromatic. Okay. Like here, this 10 aniline, it is expected to be aromatic because it satisfies the 4n plus 2 pi electrons. But since it goes out of planar, it becomes non-planar, so it becomes non-aromatic. Now here, it is supposed to be anti-aromatic. But what happens here? These hydrogens repel each other, so it goes out of planar. So it becomes non-planar. So it becomes non-aromatic. Very, very simple. Very, very simple. Okay. Now, I just forgot to mention something in this 10 aniline. I'm very sorry. So, here another example might come in an exam, which will look like this. Okay. Here what happens? This is a bridge 1. This is bridge. And the double bonds are same. Now see, there is no hydrogen in this position. No? There is no hydrogen here. It is replaced by 2 hydrogen replaced by bridge. Methylene bridge. Methylene. CH2 group methylene. Now see, these are having 10 electrons. That means aromatic. It should be aromatic. Now this, because of there is no hydrogens, there is no hydrogen repulsion. It doesn't go out of planar. And also this methylene group, it actually makes these 2 rings planar, so that it actually becomes aromatic. This example might also come in an exam.